Hello, everyone. As introduced, I'm Robert, head of the part-time scientist, founder of the team in 2008. And before I talk too much about what we want to do on the moon and why it is actually a good idea that you should think about getting to the moon and building your startup there, I will show you a very short video.
The moon, our closest neighbor in the solar system, and yet it has always seemed distant and unreachable until now. Now, a private team of engineers is working to change that forever. They come from different backgrounds, countries, and fields of expertise. But what unites them is true pioneering spirit and the will to try the impossible. Who are these guys? They are the part-time scientists, and they are full-time crazy. Audi engineers are supporting them to build and test the Audi Lunar Quattro to make it ready for the moon's challenges in the context of the Google Lunar X Prize. Together, we will take collaboration and teamwork further and reach for the stars. Wherever this mission may take us, together we are following the true meaning of Vorsprung durch Technik. Join the part-time scientists on their mission, the mission to the moon.
Okay, so I hopefully raised now enough questions that I can jump into answer. So it was a perfect introduction, but really just to sum up who we are. So we're a team of scientists and engineers that came together by the idea of competing in this really extraordinary challenge of sending a robotic vehicle to the moon. And when I first heard about the Google Lunar X Prize, I really was wondering, why are they doing this? You know, Google is putting money out there for people to send a spacecraft to the moon. And I was like, what's the reason for this? And then I understood that the reason for this is actually because space is kind of broken, you know? The space industry as we have it today is not the industry that you can use to build your startup up on. And that is what the founders of Google realized. And that is what we realized as well, but we wanted to change something. So we as scientists and engineers, we came together in 2008. We're now amongst the top 5 teams. And what I'm really proud of is that we now have 11 people working full-time in our team. So we're still officially the team part-time scientists, but now with full-time scientists, which is kind of a big achievement for us for 5 years' work. And we still have 35 part-time scientists. Just to tell you, what is a part-time scientist on our team? That's people, for example, like Jack Crenshaw. He's the guy he led the trajectory calculations for the Apollo program for all the missions of 11 to 15. So he was responsible of getting Neil Armstrong to the moon safely and bringing him back, of course. So, and he's now working on our team, helping us through the trajectory works for our mission, which is really kind of cool, because this is someone you can't hire, you know? So, as is kind of obvious, which we are really happy about, is that we managed to convince Audi to support our mission both technically and, of course, financially, so that we are capable of making this vision come true. And we're working with technical partners additionally with the German Space Center, the DLR, with a number of universities like the Technical University Berlin, Hamburg, and Vienna, and also even with certain NASA institutes. And I will show you what we do with these guys very shortly. But first of all, the really important question is, why actually go back to the moon? You know, why do all of this work? Why do you put yourself to the struggle? So where we want to go on the moon, that's actually this area. That's the Taurus-Littrow Valley. Taurus-Littrow is actually the place where Apollo 17 touched down. And we want to land there in a 5-kilometer distance to the original landing module. So that's the spacecraft where the Apollo astronauts landed on the moon with. And we want to visit this guy over here. So that's the LRV. That's the Lunar Roving Vehicle, or many people just call it the moon buggy. So where the Apollo astronauts drove around the lunar surface. That's a very special space artifact because it consists of a whole lot of materials which were never intended to be used this way. And that means that you have, for example, leather seat belts, you know, you have like fiber, nylon, a lot of stuff which is now sitting on the surface of the moon for over 42 years exposed to space. Which means that going there, analyzing the remains of this vehicle is the perfect material science that you can conduct to understand what products that last in space for a long time has to be made of. So if you want to build a lunar base, if you want to send a robot there mining resources, you really would like to know what happened to the heritage that we already have there. That's the main goal for our mission. So visiting Apollo 17. So yeah, just can you see the parking position? I don't know if the keys are still in there, but it's parked a little bit outside, 225 meters about. So the way that you can get to the moon, and what we figured out is, which it makes it possible today to not just go to space for billions, but actually for just a low 2-digit million number, is actually that you have to do miniaturization and optimization to the limit. So what we do is we use a satellite vehicle, a satellite launch vehicle, which is also not intended for this way, which normally gets satellite into orbits, which is the best commercialized area that we have in space, because we launch dozens of satellites every year. So, and with this satellite launch vehicle, we send our spacecraft into Earth orbit, and we use a small landing module. It's called landing module, but it's much more than this, to accelerate all the way over a certain trajectory to the moon orbit, and then, of course, initiate the landing maneuver. So that means that it has to be really, really small. And a landing module, in this case, for our configuration, looks like this, so that you have an image of it. That's, for example, an earlier version that we've developed to test out all of the structure elements, and that is what the current design looked like, that we're currently putting in practice. So the coloring, for example, highlights where you could actually bring technology on there. It's just important to understand the mass balancing. So, and the highlight of this mission itself is the technology that we want to bring there. So, but how do we bring the technology to the place? So how can we bring all the sensors that we want to there in our experiments? That is why we have these mobile exploration vehicle in this case. So that's what we've developed also along with the lander for the past 5 years. And we not just have to develop the software. This is kind of a robotic vehicle. You also have to do all the testing and qualification. The problem is with the moon that it has really one of the toughest environments that you can think about. You have temperature changes of about 300 degrees Celsius, temperature shifts. So we're talking about minus 225 to plus 160 almost instantly when the sun goes away. So that's kind of a big issue. Another thing is the radiation, which is 100 times more than the radiation that you can encounter on Earth. And you don't have the luxury of a protection from the atmosphere that we have here on Earth and the magnetosphere. So that you really need to you have to solve a lot of technology challenges. But if you can do this, and if you can operate technology on the surface of the moon, you can actually come to a platform which deploys the technology there. And I will show you a little bit what you could do there. So that is what the final illusion looks like of the vehicle that we are now doing the flight qualification with. And so what do you do on the moon? What does the term payloads mean? So what we want to bring to the moon, is where we always call it payloads, is technology that we think we want to put to the test there. So of course our entire mission is just a proof of an example, you know. If we want to send something to the moon for 30 million, it has never been done before. Never has any private entity at all landed somewhere in space. You know, that's a first on all points. So, and in this case, we want to pick it further with the technology so that we want to bring, for example, a number of spectrometers there, gravimeters, to analyze the environment and see what could the moon help us to, give us a commercial foundation for, subsequent exploration missions. And things, for example, that we want to do is analyze the gravity data, which on the moon, so that we can understand what is the resource composition of the surface. And also something that we want to do on our side, which is not from a third party, is something which has this quite complicated sounding name, a lunar soil additive manufacturing demonstration. Basically, it's a 3D printer for the moon. What is the idea here? The idea is to send a small unit to the surface of the moon, collecting the lunar soil, which is this fine powdered gray dust that you can see, and separating it by its parts in its melting temperature. Then making a small powder bed out of it and using a laser to produce a small metal gear. This would be the very first ever produced part on another planet solely existing out of components mined there. And that's something really, really huge important, because everything in space is currently about the rocket equation. You're needing a lot of money to buy the rocket fuel, you need a complicated rocket, you need to get there and bring all the resources with you. If we can show that we can get the resources and use them in place, which is called in situ resource utilization, then we have the key for the future of space exploration. And you have to understand the resources that the moon holds are actually things which are not so obvious, most people don't know about. The moon has large quantities of water, actually. It has, from the water you can extract oxygen, and with water and oxygen you have hydrogen. So with hydrogen you have one of the actually the best rocket fuel that you can have. So in addition to this, the lunar soil has aluminum and large amounts of titanium. So actually you have the building blocks that the moon becomes your very first gas station on the highway into space. And that's something that we want to give to the people as a vision, that they get to start and develop technology for this, so that they don't just create an app startup for today, but actually a technology startup for the future of mankind, reaching out into the stars. So, and 2 payloads that I just want to show. So, for example, this is one of our technologies that we sent there. It's one where we won an award from Google for. It's a special camera system which has these 2 stereoscopic cameras, which are just like normal human eyes, which give you 3D imaging. But the special thing is in the middle and above it. The middle camera, that's a telelens with a filter wheel, which is similar to the Mars Science Laboratory. So the rover that's currently exploring the Mars, and it has 9 different infrared filters to analyze its environment just by looking at it. So you can understand the resource composition just by analyzing the imagery, which is really an important thing. Also, you can zoom into objects that are really far away, which is the advantage of a telelens. It sounds silly from an Earth perspective having a telelens in space, but it's actually really complicated to build one which can survive all the vibrations and loads that you encounter on the way to the moon, because it's really is a tough ride. And of course to miniaturize it in this form, because it really is a small form factor. And another thing which I think is a really, really awesome experiment which we're doing together with NASA, that's the Lunar Plant Growth Experiment, and the name really suggests what it's about. It's about studying plant growth on the moon. Because right now, we know how plants grow here on Earth, we know this pretty well, and we know how plants should grow on the ISS. They have some issues there, because the plant seeds actually, when sprouting, get disoriented. And nobody really knows why. There's a lot of theories that it has to do with gravity, that it has to do with maybe radiation or lighting. But the interesting thing is, if we want to have a future in space, then we actually need to understand how plants and how we can grow plants in space, how we can actually grow fruit there. We just had a movie which was about growing potatoes on Mars. So in this case, it's about figuring out what it takes to grow plants on the moon. And this is an experiment. The special thing about it is that it's an open experiment, which means it's intended that school classes can actually download all the files, put it into the 3D printer, and replicate this experiment live while we're conducting it on the surface of the moon. So kids can actually see their plants growing inside this experiment parallel to the plants that should grow on the moon. So it's a really, really cool opportunity there to educate people to get, to not become lawyers maybe, but engineers. So that could be a really good opportunity there. And excite them for the opportunities that are in space. Yeah. So that's basically what I wanted to show you about our mission. And I really want to highlight the website that we have, missiontothemoon.com, so where we always show what we do, show you some updates, and yeah. And if you want to have a look at our new prototype that we're building, it's just over there in this cube. Thank you very much.
That is really, really inspiring, Robert. Thanks for sharing your thoughts with us. What's the name of the prototype? I know the last one was Asimov.
And this one is the Audi Lunar Quadro.
This is now the Audi Lunar Quadro, and that's the name. There's no cuddle name or something. Yeah. Okay, I see. Just let me ask you one question. I mean, I totally understand the curiosity on seeing what is happening there on the moon and doing these kind of experiments. And I learned from you there is this kind of exploration that is Earth-sided and also the one that is space-sided. But what is the benefit of making these space-sided explorations then later on? What is the benefit of that for us as humans?
That is what we have to prove, because right now, as you introduced, everything that gets funded in space by investors is all the things that look down on us, because it's like GPS technologies. But what we need to prove is that we actually have a commercial opportunity when we are looking away into space, so that we want to show that we can use the resources of the moon, like I mentioned, that we can generate rocket fuel. So for example, if you want to go to Mars, that you can actually fuel up your entire mission. If you want to fuel a space station, like the ISS, that you can actually don't have to send the fuel for, which is actually really toxic and complicated, here from Earth, but actually generated on the moon itself. And of course, what we want to prove is that it's possible for, as I said, for you guys, if you have a technology idea for space, if you have a startup idea there, that you can actually make it possible. Because right now, if you go out there to an investor and say, hey, I got this idea, then he will not get the funding because it's space. It's complicated. It's for the guys in the white coats. It costs billions. But we want to show that you can actually get access to it. And I believe a lot of cool and brilliantly minded people will show us a lot of opportunities where they can do that.
Can you elaborate a bit on the point of the innovations that you make just during the whole process of getting to the moon, that then maybe later on also find their way into our daily lives?
Yeah, of course. Some which nothing is not so obvious. We use a lot in our technology development. For example, 3D printed parts. Large parts of the rover consist out of 3D printed aluminum and 3D printed titanium in different mixtures. You can actually mix the compounds out of it to optimize them for structure and weight. So, for example, what we do, specifically together with Audi, is creating new parts which can only be created and produced in a 3D printer, that they couldn't even be created in a CNC milling machine. So what does this advantage be? For example, if you compare this prototype with our previous rover, then you, for example, you will see that the cablings going through the inside to the wheels, for example, this was a really complicated part which consisted of 3 different parts in the previous version, and we're now capable of doing it in a very thin but strong part which has the cabling already inside. It's the holding for the cabling is already in the part, which is something that you can only do with 3D printing. And you know, 3D printing is not just for prototyping, but it could be really used, in this case, for space-grade robotics to make them, you know, even possible. And there's something which I think it's kind of silly because it's the obvious thing, you know, of a return from space to maybe the automotive industry. A simple thing is the painting. We have the rover that we have has a special coating to reflect about 90 to 95% of the UV light, because thermal is a really huge issue in space, because you have the sun, you have no air, so you can't anticipate the heat, so you don't want to get the heat. So that's why we need this special coating. But the interesting thing is that we realized you can actually apply this space coating to normal cars, so that they don't heat up in the summer that much, and you can save a lot of energy and make them more economical. That's actually a learning that we had together with the guys from Audi in the development process. So there's always a back and forth between space and industry.
Super interesting. Is there one question from your side that is still burning under your nails? Enough said? Enough said on the moon. Okay, Robert, thank you so much, and I wish you all the best for the competition.
Thank you.
It's so great to know that you're in Berlin. Thank you.
Thank you.